Okay, so for this FRQ, we're going to do the question number 4 from the 2013 AP exam. And this gives us a graph, and the graph is of f prime, and you can see that labeled right down on the bottom here. So the question says, the figure above shows the graph of f prime, the derivative of a twice differentiable function on the closed interval from 0 to 8. The graph of f prime has horizontal tangent lines at x equals 1, x equals 3, and x equals 5. The areas of the region between the graph of f prime and the x-axis are labeled in the figure. The function f is defined for all real numbers and satisfies f of 8 equals 4. So that's going to be important to note. Most likely we're going to have to use that at some point. Okay, so for A, find all values of x on the open interval from 0 to 8 for which the function has a local minimum. Justify your answer. So for A, anytime we're looking for a minimum, we're looking for where the slope changes from negative to positive, right? If we're going down and then up, we would have a minimum there. So this is a graph of the slope. So we're looking for where the slope changes from negative to positive. So right here on the graph, our slope goes from negative to positive. So the name of that point is 1, 2, 3, 4, 5, 6. So I would say x equals 6, and it says to justify our answer. So we're going to have to come up with a reason using calculus. And that's because f prime changes from negative to positive. Okay, part B. Determine the absolute minimum value of f on the closed interval from 0 to 8. Justify your answer. So 6 is a relative minimum. I want to find the absolute minimum. So absolute minimums can occur at relative minimums or at endpoints. So I want to know what the lowest point is. So I'm going to test some values. I'm going to test 6, and I'm going to test the endpoints. So the problem is this is the derivative. I want to know the actual value. So I'm going to undo the derivative by taking an integral. So I'm going to find the integral from 0 to 6. Oops, I guess it should be x, not t, but it doesn't really matter. I'm going to find the integral at 8, so 0 to 8. And I'm going to find the starting point, which I'll figure out in a little bit here. So let's first see what the integral from 0 to 6 is. So they tell us that f of 8 is 4. So that's my ending position. So that means after I traveled this whole distance, I end up at 4. So they give us some areas, right? To find an integral, to go backwards from a derivative, we're going to find an area. So this area is 2. This area is 6. This is 3, but it's underneath the x-axis, so it's really negative 3. And this area is 7. So let me do the 8 first. That's probably the easiest one. So this whole distance traveled here, 2 plus 6 minus 3, and then plus the 7. That's that whole integral from 0 to 8. So that gives us 12. Okay, so let's see here. We've got 12 is the whole distance. So what else do we know? Oh, we know f of 8 is 4. So our ending point is 4. So this whole distance, I'm going to mark this on the graph here. We've done ones like this before. This whole distance is 12. Our ending point is at a 4. So what can we find from this? We can find our starting position. So if we end up at 4, but we traveled a distance of 12, our starting position must have been -8. So I actually found from all this f of 0, which is -8. I also know that f of 8 is 4. The only one I'm missing is f of 6. That's the local minimum. And so far, this is my lowest point in the graph, but I got to figure out what 6 is. So now that I know f of 0, I can probably figure out what f of 6 is. So if my starting point is -8, and I travel to get to 6, which is right here, I would take -8 plus the 2 plus the 6 minus the 3, and that'll tell me where I'm at f of 6. So let me write that down. We've got -8 plus the 2 plus the 6 minus the 3. So that gives me -3. So my lowest point of the whole graph would have to be at the very beginning, f of 0. That's our absolute min. Okay, justify your answer for this one just means show your work. So as long as you show your work of what you did, you would get full credit for that one. Okay, let's go to part C now. On what open intervals contained from 0 to 8 is the graph both concave down and increasing? Explain your reasoning. So let's start with the increasing part, because I already have a graph of the slope, right? So increasing would mean I'd have a positive slope. So let me list all the spots where the slope is positive. So the slope is positive everywhere except for where it's below the x-axis, because this is a graph of our slope. So far, the slope is positive everywhere except for here. Concave down, right? That's the second derivative. That's where the second derivative is negative. So if this is a graph of the first derivative and I want the second derivative, what I would do is take the derivative again, or find the slope of the derivative. So second derivative is negative. That's where your slope of f prime is negative. So where do I have a negative slope? Right here and right here. So in those two spots, our slope is negative and our graph is going to be concave down. So remember, this is not a graph of the original function, but on the original function, that's where we would have those two things. So I would say, and I'm going to make a list from 0 to 1, and 3 to 4, and that's because there the slope is positive, so f prime is positive, and f double prime is negative. So this is showing that our slope is increasing, and this is showing that our graph is concave down. Okay, last section, part D. The function g is defined by g of x equals f of x cubed. If f of 3 is -5/2, find the slope of the line tangent to the graph of x equals 3. So we're finding the slope, which means I need to take the derivative of this function here. So let me write that down again down below here. G of x equals f of x to the third power. So in order to find the slope, I need to take the derivative. So the derivative of this is going to be a chain rule because I have an inside part. So I'm going to start with a chain rule. That's the derivative of the inside. F prime of x times the derivative of the outside. So 3f of x squared. And we're evaluating this at 3. So I'm going to plug 3 in for x. And now we're going to solve. So f prime of 3, let's see, do I know anything about that? Nope, not from the question, but I have a graph here. So the derivative at 3, if I find 3, which is right here, puts me at this point right here. The derivative at 3 would be 4 because this is a graph of the derivative. So I'm going to plug in 4. times 3. F of 3, they give us right in the problem here. F of 3 is negative 5/2. Now, on the AP exam, you can stop right there. You do not have to simplify, so I would suggest not simplifying. But if you want to go ahead and simplify that, you would get 25 over 2 times 3 times, 25 over 4 times 3 times 4. So that would give us 75. Okay, so that finishes up this FRQ.